My trip to Intel Innovation 2023 and this video are made possible by sponsorship from Intel. My thoughts and opinions on this, however, remain my own.
You hear that? That's the song of my people.
I'm just back from Intel Innovation 2023, and boy, I've learned a lot. Intel Innovation 2023, they're kind of turning it into an event for developers and programmers, people that get to know the nuts and bolts of the system. On the internet, everything at the communication or transport layer from your computer to the server you're talking to is encrypted with very strong encryption. Well, don't we trust our ISPs or network providers or anyone on the internet between you, your computer, and the system that you're talking to on the internet? I mean, most of the time, you're not banking or managing your medical data or filing taxes. Do you really need the highest level of security all the time? Yes, you do. You really do. You need the highest level of assurance. And yet, as a user, we have very little assurance that the program that you're running is actually running the way that the program author intended, or it's running without modifications. Your operating system could be compromised, the program might have been modified. If I invent a new compression algorithm and I want to demo it for a Fortune 500 company before they decide to, give me lots of money for this awesome thing that I did, I'm really giving away my secrets of the program and the data. We don't really have a great software solution or data protection mechanism that's remotely as robust as what we use for our communication encryption. Yet. And that was kind of the subject, one of the big subjects at the Intel Innovation 2023, although it flew under the radar, I think. For any other company, fixing that problem with software would be a moonshot, a holy grail of accomplishment. But for Intel, thinking about solutions to this problem is just part of the daily business routine. And at Innovation 2023, we got more than a peek behind the curtain about what Intel has so far and what the roadmap is for the future. I can see where they're going now, and it actually makes a lot of sense. And some of it's actually available today. You can take it on, incorporate it into your own solutions, especially if you're a developer, on your local machines or even in the cloud, even in third-party commercial cloud providers. So let's take a deeper look at what Intel showed. Genuinely, actually very excited for this. The lock that appears when you visit a website ensures that no one between you and the web server that you're talking to has tampered with the web page. You might think that in this day and age that wouldn't be much of a problem. It turns out that's wrong. Just a few short years ago, many communications companies engaged in bad behavior by snooping on and even modifying unencrypted web traffic. Both Verizon Wireless and AT&T were caught adding subscriber unique tracking codes to the header of every single unencrypted website request that for websites that users visited. And apparently this isn't illegal the way that opening up someone's mail and tampering with it, postal mail, would be. And so this bad behavior sort of accelerated the adoption of encryption at the transport layer for all websites other than just commerce sites, basically every site on the internet, because that's not a valid place to try to mine more revenue. This transport layer security is a well understood form of public key cryptography, and how it works under the hood is similar to where Intel is going to go with their Intel Trust Authority initiative, Software Guard, and their trusted domain extensions, but to protect encrypted programs and data at runtime. With transport layer security, or TLS, the secret is really that there's a chain of trust. There are root encryption certificates that are bundled in the web browser program you use, Chrome, Edge, Firefox, Brave, whatever you're using. And the lock icon that shows up on the website for the encryption certificate can trace its chain of trust all the way back to one of the trusted authorities that's built in. One of those authorities has vouched for the specific certificate that's in use on a particular website. They're all unique. And there's a chain that leads all the way back. I mean, don't get me wrong, your web server has its own private encryption key. That part is not shared. It's just that you get one of these certificate authorities to sign the certificate that you wanted to use for the website, and they do something, somehow, to verify control. some level of control. It could be control of the DNS name, could be control of the actual website server, something, control of the business. There's something going on there. And that mechanism attests, it's an attestation that's, yes, this is who they say they are, and the certificate authority uses its private keys to sign the certificate request from your web server. And yeah, that's not always perfect. Symantec got into trouble a few years ago for just doing this willy-nilly, and the effect was that they had all of the certificates that they ever issued revoked, which caused quite some headache. Browser makers take this thing very seriously, this chain of trust. So it's worked okay, it's worked reasonably well for websites. So Intel's vision for security assurance is to have a protected mechanism in the processor that can decrypt encrypted data and executable code programs that neither the user nor the operating system they really have access to. It's running at a hardware level. The plan is to offer varying levels of assurance about the environment, down to individual machines or a specific cloud provider or a specific customer instance within a cloud provider. You can partition the machines however you want with hardware identifiers. So, for example, you could upload your program and data to the Intel Developer Cloud in an encrypted form, and you can configure your program to only execute on machines that are linked via the same sort of chain of command, the chain of trust command, only in the Intel Developer Cloud. Thales was the security data platform that Intel showed at Innovation 2023, and that provides the signatures and attestation services. So you enroll your own on-premise servers and the specific servers associated with your account in the Intel Developer Cloud, or any cloud, Oracle, Azure, whatever, and the attestation mechanism will make sure that those servers are running in a standardized way. They're not set up to steal your stuff. It's a mechanism not super far removed from how we already approach end-to-end communications encryption for the web, the same sort of chain of trust, the same sort of attestation mechanisms, except there's some hardware in there to also attest that the processor is running within spec. I mean, it does mean that you're trusting Intel microprocessors, but it effectively reduces the surface area of companies that you have to trust. You don't have to trust your cloud provider, as it turns out, because the chain of encryption events means that the cloud execution environment is verified by an external third party, potentially even at runtime if you want to, and specific machines. So if you had loaded your data in the Oracle Cloud, or Azure, or Google Compute, it does not mean that you also trust those companies, because the encryption and the decryption is happening in what Intel calls the secure enclave, physically on the Intel processor. Neither the cloud provider nor other tenants leasing space from the same provider have access. And unless they have access to your specific tenant in the cloud, they're not going to be able to access the unencrypted data or the unencrypted anything, or even to have the ability to attack that surface area. And where Intel is going with software guard extensions and their trusted domain extensions, TDX is sort of new. I mean, TDX was announced in 2022, but the idea with TDX is to encrypt the whole container, or the whole virtual machine, not just the sensitive parts of the application, as was the approach with the earlier SGX implementations. This makes it a lot easier for devs to leverage features over SGX when we're talking about TDX without reworking a lot of applications. You can just package up the whole application, put it in, and you're good to go. At Intel Innovation 2023, they said they were working on application-specific silicon, an ASIC, that will be the processor to handle the security work with better speed and lower overhead. Basically, it's challenging the rest of the environment around it to ensure that it's remaining secure, that you don't have an unscrupulous cloud provider. Much of Intel's coverage for their vision here is to benefit companies or anybody looking to protect financial and medical data, even during compute in the large scale. But an individual will also directly benefit from this, I think, because this approach to software security is far preferable, in my opinion, to what we have now on client computers. I mean, it's not great. It's not great what we have now on client computers. Everybody watching this video could benefit from this kind of an approach. You probably don't even realize just trying to use your computer for innocuous things, there's a sort of holy war raging in the background of epic proportions between different software companies. It's like, I just want to play some music. I just want to watch a movie. It's more complicated than that. I mean, lots of companies are already behaving very badly in this space, just as Verizon Wireless did in its misguided attempts to control your web browsing experience by injecting their own cookies. Take, for example, Sony. Yes, that Sony Entertainment, Almost 20 years ago, Sony put malware on their audio CDs that, when used in a computer, would sabotage your ability to burn audio CDs, like CDRs, as some sort of misguided attempt to protect their copyrights on music. The software was invasive, and it modified the core of the Windows operating system, which is an egregious violation of user trust, certainly, and most probably illegal. Several states' attorneys general had filed suit against Sony BMG. Gamers today endure the same sort of thing, almost as bad, anti-cheat software. How does a game company ensure that there isn't another program running at the same time as a game tampering with their game program? Or to ensure that the user hasn't tampered with their operating system to hide stuff from the game so that people can cheat? I mean, a lot of these games you can play for money, they're competitive online, there's a lot of components here, there's a lot at stake. And most game companies take the same sort of yucky approach that Sony employed almost 20 years ago to varying levels of yuck. Operating systems, both Linux and Windows, have started to cryptographically sign both drivers and executable programs as a way to try to steer companies back toward the light and make the environment a little bit better. And it's not perfect, but it has a lot of gaps when we're talking about certificate-based verification. SGX is a different direction, and it's more about granular control down to specific machines or groups of machines. SGX can ensure that the important parts of the program haven't been tampered with, and that it is executing on the computer that it is intended to execute on, like the specific computer or the specific group of computers or the specific cloud vendor. And I would much rather have something like what is contemplated by the SGX design protecting game code or running an anti-cheat routine than something that's more akin to the Sony rootkit design. The Sony rootkit design is basically still here, and we're all suffering with that kind of an approach today on our client computers with a lot of software. Installing kernel level drivers that are always on all the time for a game that you're only opening sometimes just seems like madness. And sure, it might be possible for dishonest companies to use SGX in ways that are unfair to end users, but at least in the case of game anti-cheat software, it would be totally unnecessary to abuse the users if all you're truly worried about is someone cheating in a game, because you can protect those parts of the game. Now, SGX has been around for a while, 6-7 years, usable and viable. Intel pivoted what SGX means in client devices in 2021, though, in part because SGX had not met its design goals in desktop computers. As a result of this pivot, some software that relied on SGX in the client broke around 2021, 2022. Most famously, HD Blu-ray disc playback software. A lot of those pieces of software just stopped working without warning on 11th generation and newer Core Intel Core processors, because most of the officially industry-sanctioned Blu-ray software used every protection that it possibly could, and so it just stopped working. I mean, it makes sense, right? Protect the Blu-ray decryption program and the decryption keys with this hardware encryption module that will protect the software. But Blu-ray owners were stuck, and the only way to play back HD Blu-ray discs was to switch software to other software that didn't implement SGX extensions, and there's maybe a little bit gray market as a result of that. And part of the problem was that in desktop CPUs, features like overclocking and undervolting, which are very popular with enthusiasts, also mean that some of the protection machinery that exists in the SGX extensions physically in the CPU can malfunction, which will then expose the secrets that they're supposed to protect. Plundervolt was one sort of famous security disclosure, but even in Windows 11, Intel's own extreme tuning utility, one has to turn on undervolt protection and turn off core memory protection in order to use this software because of changes to the platform. Like the operating system is trying to use some of these features that fit under this umbrella, but if you want to use overclocking, you have to turn some features on and some features off. So it's a really interesting situation in the desktop. Server doesn't have that. Nobody's doing crazy stuff like this with server operating systems. They just want it to be secure. And for desktop, that backstory is why Intel said at Innovation 2023 they're working on an ASIC, an application-specific IC, to handle the security part of this.
So we're working on an ASIC accelerator to reduce the performance overhead, and we expect to see massive improvements in executing fully homomorphic encryption workloads on existing CPU-driven systems, which is key, and reducing the cryptogram processing time by 5 orders of magnitude. This is the big inhibitor to getting homomorphic encryption widely deployed. is this computational challenging problem. But who's really good at figuring out computational challenging programs? Intel Labs. And this is what we're working towards.
But the trade-off is that you get better security and better performance, but it's happening on the processor, but outside the part of the processor that enthusiasts can get in there and muck with. So for security and attestation and chain of trust components, Intel is actually a lot farther along than you would guess if you only just saw the Innovation 2023 keynote. And there's a lot of context there that you might not have been aware of. Hopefully this video will help you with. If you are a developer, there are some things you can get right now that I want to show you because they're exciting as heck. First, there's Grameen. Grameen was recently renamed. It was called something else, and then it was something else before that. But Grameen is a fully open source compatibility layer for SGX that makes it super easy to package Linux binaries to be able to run in a secure enclave. So if you're developing software or doing some cool algorithm and you want to run into the cloud and protect stuff, you can. You can package the important part of your application and protect both the program and the data from tampering or prying eyes. You invent a new compression algorithm, great. Use this to protect it before selling it to a large company, and you can run all kinds of tests in the cloud and have a lot of fun with it. The Azure Marketplace is also a good place to look for Intel confidential computing or, Grameen-based stuff. I mean, it's so feature complete, you can get an implementation of PyTorch built on Grameen on Azure right now today. So if you use PyTorch for anything high level and you need security functionality with no impact or heavy code modifications, well, you can run that right now today. Your PyTorch application is immediately portable and runnable in this context in Azure. And Microsoft wouldn't have access to snoop on whatever it is that you're running on their computers. You can be assured that it's happening at a hardware level. Now, I joke about this as it's snooping, like Microsoft would want to actually snoop on your data or any of that kind of stuff. But this is actually by far and away the easiest way to assure things with like HIPAA compliance and medical data. If you've got a big AI project you're working on and you need a lot of compute, this approach would pass your HIPAA audit and let you securely upload patient data to the public cloud. And building your application architecture around this, you're doing more than most companies to protect data, which is great. And as an end user, I greatly appreciate. Intel also has this neat GitHub page that they call the Confidential Computing Zoo, and that's worth a look if you're a developer to get some ideas for a starting point. There's a lot of really cool projects here that you could import or use as a basis for your own project. I mean, you can even generate and manage SSH keys from the secure enclave if you want to start with just something basic. I mean, effectively, you're securely enrolling a specific device to allow SSH connections, and you're protecting the keys from the end user and the operating system from having direct access to them. But you can still use SSH through the secure enclave. That's a pretty neat, basic, but not basic, but a good way to just get your feet wet with this kind of technology. And it really is encouraging to hear Intel say that they are committed to an open ecosystem for all of this stuff. They had Red Hat on stage, they had Canonical on stage, and both of those companies are using this technology right now today natively in Linux. So definitely go check it out. If you look at everything that's happening around us with AI and software and this kind of thing, there's never been more entrepreneurial opportunities for developers or visionaries or creative thinkers to just use these tools and build something really pretty great. The low-hanging fruit is better than what we have right now. So check out the links I've shared, and Thales, Intel's confidential computing platform, and Innovation 2023 coverage and the other stuff that I'm sort of putting together. Check out the keynotes and all that kind of stuff. But where Intel is going with SGX and TDX is actually pretty exciting. And you can take it all for a spin today. Now, Intel sent me to Innovation 2023, but you can bet that I'm going to be looking in on them for Innovation 2024 and just see how much progress they've made down this path. I mean, just because we can talk about it, talk is cheap, but the execution is where we've got to actually get our ducks in a row. So be sure to check out my other innovation coverage. Oh, and one final thought. Wouldn't it be awesome if you didn't have to decrypt the data at all, but you could just do the computation on the actual encrypted data? That's called homomorphic encryption, and we don't actually have a universal mathematical underpinning for that yet. Everyone is aware of it, and it's on everyone's computational radar. Intel mentioned it in their keynote, and that is the holy grail of solving the confidentiality problem. We're just nowhere near ready to be able to solve it at that level yet. We just don't have the plumbing. I'm Wendell, this is Level 1. I'm signing out. You can find me in the Level 1 forums. Oh, and hit me up if you've got any questions. I would love to answer them or clarify or frequently asked questions for this kind of stuff, because some of the resources for, okay, what is it? How do I use it? How do I leverage it? Not super clear even to me. So if you have questions, let me know. I'd be glad to hear what those are, and that might help shape future content. So, all right, I'm signing out, and I'll see you later.